means like the kind of one thing that the introductory part, and as and when I get the time, I will continue the session. As you know that it is, I mean to say that talking about this topic in front of Edris, it is little bit, I mean to say that very fundamentals and may not be that much good also. He is having the extensive work on this kind of multi-level inverter topologies and the high power inverters, and good amount of work is done on this topic. So that as on date that you got exposed to this kind of thing, that is the my topic when it comes to hybrid energy storage systems and different types of bidirectional DC-DC converters, and then this thing that you are having the fruitful sessions with the Edris about different grid forming converters and what we can say then this space vector things, microgrid, smart grid, and other things, Clark, Park transformations, general model analysis of grid connected converters, and dynamic model analysis, all these things that you have come across. So now the thing I am going to take you to the means like it is not the different part, but the part of your course also. This will be that the inverted concepts. Most of you that you are, how many of you are working on this kind of inverted part? Is okay, I'm sorry that I can't. Okay, yeah, inverters. Is there what's the functionality? Most of you are aware that the UG students are also is here. So inverters, what's the functionality of the inverter? What it is going to do? You are listening to long lectures, and the first day that we had the discussion, there are 4 different types of conversion that you are working: AC to DC, DC to DC, DC to AC, and AC to AC. Yes? Now you are yes? Is there working? Any of you are working on this inverted concepts? This I think that you are hearing about this space vector pulse width modulation technique for what type of inverter that you are making use there? Yes, from Edris class, and you are giving how many pulses that you are giving it to your system? How many switching pulses that are you giving? Yeah, how in your system how many switches are there? Is it like, yeah? Yeah, 6 switches will be there, and okay, is there any means like 6 switches and you require the 6 switching pulses are required. Is it okay, satisfied with your switching pattern? What's the means like how many voltage levels that you are going to obtain from this system? How many voltage levels that you are going to obtain? Are any restrictions or of any kind of things that you do face the challenges in this kind of system? Yes? Total THD part, that is the total harmonic distortion part. Yeah, one query. Yeah, any other than this? Yeah, okay, I will come back to you. Yeah, THD part she is talking. Other than this one? Other than this one? Yeah. Yeah. 2 level, 3 level, 5 level, but your topic is restricted for the 2 level. Yes? Yes, that is the 2 level inverter topology that you are making use. It is like an ideal condition that the switch either it can be of 0 state or of a plus VDC state, or of 0 or of minus VDC state that you are having. And the restriction might be knowing that you can't go to the higher power levels. You are all the systems that you are going to make use of the power semiconductor devices. Power semiconductor, there is a restriction of your voltage rating and the current rating. You can't go for the higher. So if you want to go for the high power application, that series parallel connection is very much essential. So, the main restriction of not going for the high voltage or of high current rating is because of that the voltage stress or of a current stress which is going to experience across the switch part. Okay, that makes you to restrict to lower your working power level. That is what we can say that. So, and also that she is saying that means total harmonic distortion part. This total harmonic distortion part for the ideal cases that the professor is saying that we are supposed to maintain the close to around 5 to 10%. Okay, it is the ideal condition. If you won't maintain the total harmonic distortion within the permissible limit, that you know that the pulsation, overheating, and the machine performance degradation is going to take place. That should be avoided. So, how you are going to improvise the total harmonic distortion? Here, that the conversion part you are doing, what you are doing the conversion from the, again your system is going to be of a AC system, that you are talking about a 3-phase machines. 3-phase machine, and it is in the form of that you require to provide the required voltage and the frequency to get speed control over the system. Okay, that the V by F ratio that you do maintain constant, accordingly that the voltage and the frequency you are supposed to maintain constant to get the different different speed condition. Now, the question means like how you are going to improvise the THD. One question you are saying that increasing the number of steps, okay, that you are means what will happen? Improvising the number of steps means I can increase more number of levels. Okay. Now, our topic restriction is going to be like up to 6, 7, 8 and 9 level, maximum of 9 level, that the discussion is there. Can't we go behind the 9 level? If you go behind the 9 level, what happens? Or within the 9 level, what? Huh? What? Can? More number of switches are required. Yes, that is. Control logic is going to become more complex. Yes, that is the will restrict. But the advantage, this is the one disadvantage part, that the control logic is going to be of a little complicated, and then more complex circuitry is going to be. That is one thing. And okay, another part, this part is okay, disadvantage. Advantage is what? Yeah, the objective is that you want to make it your output voltage waveform or of current waveform as close as possible to the sinusoidal waveform by increasing the number of steps. So that if have the sinusoidal waveform, then your machine performance can be improvised and the harmonics can be reduced. You can brought your THD level below the means like close to 5% or of required standard, that you can bring it. That is what that this inverters part are meant, multi-level inverters part means like here restricted, then I am giving the flavor of it, that most of the people also that they are working. And if you want to realize the multi-level inverters part, I think that most of you did come across this course also in your UG curriculum, PG curriculum. What type of multi-level inverter, conventional multi-level inverter that you have you have come across? One is diode clamped multi-level inverter, flying capacitor multi-level inverter, and cascaded H-bridge multi-level inverter, that the more modularity that can be obtained from the cascaded H-bridge multi-level inverter. Okay. And these are the only multi-level inverter topologies you have, if you want. Yeah, modular multi-level, that is the extension of cascaded H-bridge multi-level inverter, that repeatability, redundancy can be easily obtained by using the cascaded H-bridge multi-level inverter. Yeah, these are the things. If you work with the multi-level inverter topologies for high power applications, so then what you are going to look into the system? there are two areas to work in this kind of inverter. What are the means? One, I mean to say that is the structure development. By using the less number of switches, you can achieve the more number of levels. Okay, that is one area of research. What we can say that by using the less number of switches, increasing the more number of levels. That is one thing. Okay. For example, I can give it to you in the case of a cascaded H bridge. You have the two types of configuration. One is the symmetrical configuration and the another one is of a asymmetrical configuration, we can say that. If you make use of the asymmetrical configuration with less number of devices, less number of DC sources, that you can achieve the more number of levels, but it is not going to be fruitful for the modularity concept. Okay. Similarly, this is the one thing, and another challenging is that, what is the challenging? You have this there are means like many structures, many of the authors, those who are working in this kind of multi-level inverter, optimization of the number of switches to increase the more number of levels. That is what we can. And the other concept, what is the, yes, control. Yeah, that is the generation of the PWM signals. Means PWM signal, there are a wide variety of what professor is discussing, what type of PWM that is discussing. Yeah, space vector pulse width modulation technique, and you have the 8 states. Okay, that is what is discussing. That the similar concept, that if you can apply for a 3-level multi-level inverter, how it is going to be 3-level and the 4-level, 5-level space vector pulse width modulation techniques. More number of triangles, more number of means like reference vector, and then the complex number of states are going to be more. Okay, that I can give the statistics about this one. And then it is popular, means like analysis at the means like 3, 4, 5 level analysis is popular, and is having good work also with the professor. That's the reason I can't means in front of him it is difficult to spell it out all these things also. Okay, yeah, fine. So these are the things. Now the importance is that we want to make our output to waveform as sinusoidal waveform as possible, and the restriction is that with the 2 level we can't go for the high power voltage and the current level. And also one more advantage, what we mean to say that the stress across the switches. This is the point that we are going to make use. You may have the series connection and the parallel series connection, so that the voltage rating is going to be reduced. That is one thing. That if you reduce the voltage stress, you have the more advantages. Means like what we can say that improvised THD part, reduced rating. These are the things are going to be there. And for development of this multi-level inverter topology, what are the things that you require? What basic components are going to be there in your inverter? You are going to do the conversion from the DC to AC, okay, fixed DC to the variable voltage, variable frequency output waveform. That the DC and the output which is going to be in sinusoidal. Yeah, basic components are going to be of the sources. Okay, DC source, number of DC sources you require, power semiconductor switches, that the diodes, filters, DC link capacitors are going to be there. Okay, these are the filter basic DC sources, DC link capacitor, power semiconductor switches, then the electrolytic capacitor to clamp the voltages, and then okay, yes, anything. Yes, that's it. So then fine. Now the thing is that with this basic components that we are going to develop the structure. That the structure, how either it can be of, you augment the, you will make it that means like you are much familiar about the H-bridge configuration. Yes, H-bridge configuration, simple configuration, inverter module. It is a single phase inverter module that you are might be of much familiar about this structure. I mean to say that you are much familiar about this structure, and then the load part which is going to be connected here, okay, and then this one is going to be of your DC source, S1, S2, S3 and S4, load part, that you are going to make use of this standard structure for the what we can say that for the H-bridge. So, this operation you are much familiar, yes. These two are of S1 and S4 are of complementary, S3 and S2 are of which are of complementary in fashion. So that if you want to get positive, these two switches are going to be turned on, and opposite for the negative voltage S3 and S4 are going to be turned on the condition. Now the condition, if you want to have the more number of levels, okay, my power rating wants to have the more number of levels. So, the output of this one can be taken as the input to the means like that the output level that can be given to the next level, and it can be cascaded, so that the one output of this one will be given to the input to the next level, and then next level that will be given to the next, so that the output level is going to be increased. So, initially that I mean to say that you have the means this kind of structure you do maintain, okay, and then you add all the edges, yes, will be there. Then adding this one, you want to make it by increasing the more number of steps, okay. You want to make it your waveform as sinusoidal as possible, okay. This will be like this one. You want to make it, okay, staircase waveform, staircase, and then this one is of sinusoidal, you want to make it possible. This is what basically now I mean to say that you have the basic converters, I mean one is the cascaded H-bridge multi-level inverter topology, and the second one is of I mean to say that diode clamp multi-level inverter topology, and the third one I mean to say that you have the flying capacitor multi-level inverter topology. This is the structure part, okay. Structure development means like a basic conventional thing. Apart from this one, you have many things. When it comes to the modulation part, that we will discuss later on, but as on date, you are much familiar with modulation techniques. One is the space vector pulse width modulation, and the real time implementation that you are doing in the laboratory, SVPWM, okay. Apart from this one, we have the carrier based and PWM tech, means like we have the classification, wide variety of classification that you have. One is carrier based PWM technique, here phase shifted and the level shifted PWM, third harmonic injection, means optimized selective harmonic injection, these things that will be there. I don't want to go more about all these things, just to give the some fundamental overview that we are going to have this kind of topic. So, now you got this thing, output amplitude part, I mean to say that, and then this one is with respect to time. So, Now the restriction of your, what we can say that the two level we don't want to have, means like I mean to say that that the two level, it is like when it comes to the two level part, what is means like basically if you take this one is yes, switch will be there. So you have the, what I mean to say that the two level switch, like a ideal switch I mean to say, yes, I don't yeah, I can say a switch, conventional switch, I can say that it is connected to a kind of a DC, so yeah, switch SW. So I mean to say that when the switch is in on condition, what kind of things will be there? When the switch is in off condition, what the things? Voltage 0 and the current should be of maximum. Okay, it should be like a, what we can say that short circuit condition. And when the switch is in on condition, it has to offer the higher voltages and the infinity resistance, and the current should be of 0. Okay, this is what ideal switch functionality. Here we are going to make use of what, here we are going to make use of the power means like that the switches are going to be means like practical switches. This the practical switches, I mean to say that either it can be of most popularly BJT, IGBTs, MOSFET, okay, and you are talking about this silicon carbide devices or germanium nitride devices, those things will be there, and you better know about the thing. When I talk about the switches, that the only thing that either it is a single pole double throw switch, that we are going to have the two states. One, what we can say that on condition that the voltage which is going to be equal to the VDC. Okay. When it is in off condition, state 2, off condition it is going to be, on condition what's the voltage? 0 voltage. Yes. And when it is in off condition, we output voltage which is equal to the source voltage VDC, and then when it is in on condition, what's the current here? Yeah, maximum. And then that the resistance part, I equal to I load current, which is going to be here in this case it should be of 0, and the resistance part here minimum 0 resistance ideal cases, and then here it is going to be resistance is going to be of infinity ohms. That is what the ideal switches. Now that the same functionality, it is similar to like either mechanical switch that you are going to make use in your electrical machines laboratory or something, conventional switch, here also that the functionality is going to be the same. But now the restriction when it comes to our practical type of inverter model, we are going to make use of the power semiconductor devices, either it can be of MOSFET, IGBT, means like you can say that mostly BJT part, MOSFET, IGBT. Okay, other than this one you are having gallium nitride and silicon, these materials also, that I am not that much depth about this one. Okay, for our experimentation, this is what somewhat more popular, we have the modules in this one. Okay. So now that the maximum rating of this one also is restricted to the some I mean 3.3 kilovolts with a current rating of 1500 500 to 600 amperes is a more advanced one, we can say. Then the rest of the thing, that if you want to go for the high power rating, that we have to have the series connection of the things. This is what that the overview of the things that we are going to have. If you see that when it comes to the this kind of things. Levels that are obtained from the conventional inverter models, either from the two level, either plus VDC to 0 or 0 to minus VDC. This is the conventional way that we can have. What happens? One of the basic problems while doing the power conversion is the harmonic contents in the output voltage and the output current part. That should be of reduced. How we are going to achieve? By making use of this kind of multi-level concept, that we are going to achieve the reduced THD value, that the harmonic content is going to be reduced. Harmonics can be minimized either by increasing the number of voltage levels or by using the appropriate modulation techniques. And this is the same that I am stressing the focus on this part, that we can reduce the harmonics part by increasing the number of voltage levels or by using the appropriate modulation technique. This is what we want to achieve, that the sinusoidal waveform means like we want to achieve this one. You know that the power quality, you people will talk also on this kind of things. If it is of means like good quality, it should be of give the sinusoidal output. If even though that the inverter, that we do accept even with the square wave output also, that the torque is going to be of pulsating in nature and the machine performance is going to lowered. So, that should be make it if you give the quality, and indirectly that you can see that a jerk kind of movement, a lot of friction, heat generated. If you touch the motor or for running for certain time period, you will experience the heat, and smooth operation continuously will run it with the quality power supply, that the heat produced is going to be of lower, that can be minimized. This is what we can say. Harmonics can be minimized either by increasing the number of voltage levels or by using the appropriate modulation technique. Different PWM techniques has been used for the means like you have the wide variety of PWM technique. That the best one how you are going to choose depending on your total harmonic distortion. If the total harmonic distortion is of within the permissible limits, you say that okay, this is the best opted for your application part. And then useful in best suited for the renewable energy sources with the grid and the electric drives. Okay. Each and every means like distributed energy sources are connected with, even that your solar photovoltaic systems are embedded with the small inverter modules. Okay. Small inverter modules that can be best suited with the renewable energy sources with the grid and the electric drive, that you want to inject the power to your grid by matching the frequency and the voltage, that can be done with this kind of multi-level inverter part. Yeah. So, then next when it comes to see this one here that we have the 2-level output and the 3-level output and the n level, and the finally that what we can say that is the sinusoidal waveform that we want to focus. Yes, here you have yes, here we can see that even this form of application also can be acceptable. It will get the means like a square wave output. It is also that we have the AC output plus VDC and the minus VDC. It is of a modified one, that we are getting 3 level in this case. Okay. 3 level means like 0 plus VDC and minus VDC part, and here 7 level that I made and the n level that I have not represented. 7 level that we are going to have the 0 plus VDC plus VDC plus 2 VDC 3 DC minus 0 minus VDC minus 2 VDC minus 3 VDC. Okay. It will get the things like that. So, now this multi-level inverter involves utilizing the higher number of active power semiconductor switches to perform the power conversion in small voltage steps. This is what we will get finally, that we want to, our objective is to get that the original waveform close to this sinusoidal waveform, that can be achieved in smaller voltage steps. Okay. So, This can be the advantage of making use of multi-level inverter. It produces the high power and high output voltage, okay, with same means the same rating of the power semiconductor switches that can be made it to cascade, making use of the multiple units in series connection. It increases the voltage, and also this kind of things also same that we are going to make use of this structure. It can be cascaded, that the name itself, that is the cascaded, that I will show the structure. This is the standard structure that I will make it series connection and the parallel connection to get the higher output voltages. Okay. So, can be used has the advantage, eliminates the need of means here in the case of what we can say that conventional thing, if you want to step up or step down the voltage, that you will make use of the transformer. Here there won't be any usage of the transformer for your application. Without making use of the transformer, that the voltage levels can be increased or it can be of decreased. That's the inverter, means without making use of your transformer, that the voltages can be raised up or it can be lowered. That one thing. If the transformer is present, what happens? That the question also posed. Yeah. Losses is one thing, and then losses is that can be of one concept we can say, and the other thing, yes, that we are saying that the high frequency transformer, and here no concept, that the line frequency transformers which are of bulkier in size and means consumes more space in your system. So, that is the two disadvantages, and if the transformer inductive, any inductive component is present, that the response of your system is going to be of slow down, that the sluggish means like that output is going to be of reduced. That can be avoided these things. We don't have the transformer, and has the advantage of clamping the voltages, which prevents the need of fast switching. Okay. That clamping restricts the switching operation. Can be used for reactive power compensation, that you are discussing about the frequency variation, that the frequency variation is going to support the reactive power up to certain period. So, this can be reactive power compensation, can also be used renewable energy, adjustable speed motor drives, high power, medium voltage up to ranging from millivolts to 3300 volts with a 9 level inverter, that can be made use. This one we can say, and then yeah. So, that the performance of this one, that can be measured by using only one parameter, means there are many parameters whether our transformer functionality is performing good or not, and which factor that you are going to decide. One factor is of a means like total harmonic distortion, that we will take into the consideration, and other than this one we have other parameters as well. You see that the one functionality I have taken, okay, it is a measure of closeness in shape between the waveform and its fundamental component, which is defined by this expression, okay, harmonic distortion. If harmonics is a harmonics means it is a kind of a disturbance. I mean to say that if more harmonics are present in your system, harmonics is equal means like what's the meaning of harmonics? Yes, multiples of the fundamental frequency, but what is the role of this harmonics? How it is means like plays in your application, in your system? Yes, they will distort the wave shape, and means like it is going to create a kind of a disturbance to your system. Harmonics are disturbances, means like it should be eliminated to the extent possible, okay, and it is a disturbance that it is multiples of your fundamental frequency component, okay, that the fundamental component alone is going to contribute towards your output voltage, okay, then the rest of other things won't contribute anything, but even though that the magnitude of this harmonic is very very less as compared with the fundamental component, that should be avoided, means like should be eliminated to the extent possible. This is what, if the harmonics which are of undesirable component, undesirable thing in your system, if it presents, these are the consequences. One is the, it generates the pulsating torque, heating in the motors, oscillations, interference, failure or damage of electrical components in your power system. It has to be avoided. Okay. And then now these are the things that we want to make it improvise by using the converter, your multi-level inverter concept that we are going to make. So that the basic things, these are types of conventional multi-level inverter topologies. One, what we can say, that major objective that we want to get the higher level of output voltages using either cascaded or of different types of multi-level inverter to compare different modulation techniques, minimize the THD value. That is the objective that we can. Types of this one: flying capacitor multi-level inverter, neutral point voltage clamping multi-level inverter, cascaded H-bridge multi-level inverter topology. That so that the formation of this kind of multi-level inverter topologies is associated with the DC sources, DC link capacitor, active power semiconductor switches, clamping diodes and the capacitors part. Okay. So, which one among this one is of more popular? Yeah, cascaded H-bridge is more popular. Okay. Why not with this diode clamped or of neutral, diode clamped or of flying capacitor multi-level inverter? Voltage? Okay. Okay. That the classification of all these things is based on the classification of this basic conventional multi-level inverter topologies is based on what? Yes, basic difference is there. Mm-hmm. Hmm. Okay. Uh. Yeah. Any? Yeah, that is fine. Based on the application, these topologies are of popular. Yeah, fine. But also there is one more restriction is there. One more classification. You know, yes. Voltage balancing, that is also there, and also here you require this one, this FC multi-level inverter and the neutral point voltage diode clamped multi-level inverter are going to make use of a single DC source, whereas this one cascaded H-bridge is going to make use of the separate DC sources. Okay, that is one thing. And also what is saying that the depends on the application part. We are, means like I mean to say that we are that much means like poor in the application part, generic study that we have done, and our work also. This one is done by, means like my student work, means like he has done restricted to the simulation part. He has gone to the 7 level. You can see that the 7 level, you can imagine that if you want to achieve the 7 level by using cascaded H-bridge multi-level inverter, how many DC sources are required? How many DC sources are? 3 DC sources for a single phase system. If you want to go for the 3 phase network, 3 phase system, that you require the 9 DC sources are required. So sometimes that is the matters. Getting 9 DC sources in a single department, yeah.
Yeah, basically this type of technology are used for the PV.
Yes.
Because, yeah, we have the multiple output from the PV panels.
Yes.
Yeah, this is why we said that application is important.
Yes.
Yeah.
Yes, that the PV panel, this is of more distribution is going to be more, and the PV application is more popular, that the generated individual PV unit, they have this kind of arrangement, and then that can be given to injected to your grid. Okay, that these are more popular for the, this one is more popular for the distributed energy sources. And then this flying capacitor and the diode clamped multi-level inverter, they are going to make use of a single DC source, okay, that can be stepped up to the get the more number of voltage levels. That is the one thing. This one is there. So, if you see that, yeah, okay, yeah, I thought, okay, that the generic structures, I mean to provide this thing, then afterwards we will have the depth discussion, the thing. Okay, I think that this is the generic one 3-level flying capacitor multi-level inverter topology, which I projected here. So, it is going to require the large number of capacitors that and you know that large number of capacitors it is going to. Capacitive component is more expensive than the this, what I mean to say, that is the diodes component, clamping diodes. The expensive part also requires large number of capacitors. For M level inverter, these many capacitors are required, okay, M minus 1 into where M is the number of levels. Okay. Selection of switch combination is going to be very complicated, that the switching frequency needs to be higher than the fundamental frequency. This is generic structure that I provided. And then another thing, I think it is from him only, this is the diode clamped multi-level inverter, that it is going to make use of several diodes in a single leg. I think this structure is this structure is meant for the 3-phase system. Okay. This one also it is meant for the 3-level, that we are going to make use of the 4 switches. Okay. 4 switches multiplied with 3, that is the 12 switches that we are going to make use, and then clamping diodes for each leg, this D11, D12, and the DC link capacitors are DC link capacitors are required is of 2. That the I given the generic formula about to do the simple calculation, but many more compared to parameters are there, but to basic comparison which I provided requires different voltage ratings for blocking the diode, unequal switch device rating, capacitor voltage balancing, that you are talking about this thing, neutral point voltage balancing and the generation of the common mode voltages, that professor is stressing here. Okay. That how to eliminate, what are the consequences you are having for having the common mode voltages. Yes, this thing. And the table also that we have means switching operation at any instant of time, that I mean to switch say that switching S11 2 for a 3-level at any instant of time, that the 2 switches supposed to be on. If it is of a 5-level, 4 switches supposed to be on condition for getting the different levels. Okay. This on off, I will give more about this thing. Then the other things, this diode clamped extension for this 3-level, 5-level, that I means like more number of diodes are going to be there for each leg configuration. This makes you to be more complex. This I think it is for the 5-level, that at any instant of time that the 4 switches supposed to be on condition. These are of complementary function. One we are getting for the line redundancy and the phase redundancy. These things will be there in means like all these things can't be covered to the extent possible. We will see that. This is what I am projecting, 3-level and the 5-level, and 4 complementary pairs are required, S11, S2, S2 dash, S3, S3 dash, S4 and S4 dash, that we are having. Then yeah, okay, this one also I can say you, I will come back this one. and this is the generic structure what we projected here, H-bridge module, and then the two states, plus VDC for getting minus VDC, how the operation 3 voltage that we have projected here. Yeah, fine. And then the row, okay, that the switching operation, we have this thing, that the switching operation and this thing, all the things will be there. Yeah, simple, that the operation, I am not means like that the stress across this one, it is a well known topology that you can easy for you cakewalk how to switch, means like for to get the plus VDC, minus VDC and the 0 state, that can be easily obtained by this one. So, now may not be that much stress across this one. Then if you go for this one, here that one, what we can say, that two cascaded two DC source, two H-bridge modules which are cascaded. Output of one is given as a input to the next one, and then that the V output which is equal to that the combination of output which is generated by the H-bridge module 1 and the output which is generated by the H-bridge module 2. V output which is equal to V1 plus V2. Okay, V1 plus. Here how many levels that we are going to get? Phase level and the line level. Yeah, 5 levels that we can get it. Yeah, 5 levels means like 0 plus VDC plus 2 VDC minus VDC minus 2 VDC, that you can get it. Two cascaded H-bridge which are connected, it is having the, means like I mean to say that these are the 5 levels that can be obtained by using this one. That the waveform associated this one, I mean to say that, you know, cascading, superimposing one output over the other, that addition of this one, this is what you are going to obtain, output from the H-bridge module 1 and the output from the H-bridge module 2. This is what cascading, adding up this one, that you are going to get this kind of waveform. Okay, that the plus VDC plus 2 VDC minus VDC minus 2 VDC, that you are going to obtain for this one. And also it is a simple basic inverter module, that the output voltage and also harmonic content that can be analyzed by applying the Fourier series or of a Fourier transformation, that the expression I will give directly. This is what means like different harmonic, that the maximum output how we are going to get, that can be. These are of switching angle alpha 1 and alpha 2, that will be the switching angle, that you will get total voltage is expressed by the Fourier series with the hard harmonics. Yes, certain, yes. So, suppose that you want that can be calculated proper selection of switching angles, that is the alpha 1 and alpha 2, that can be done by using some kind of iterative method, that you will calculate this one. I do have the algorithm for this one, but we do some harmonic that can be eliminated to solve, means like eliminate the harmonic, that Newton-Raphson method or of iterative method, that we can see the things. And one more thing, there is a for eliminating the harmonics using the delay angles, maintaining the particular amplitude modulation, that this amplitude modulation also very means like that the important, that the amplitude modulation also how much that you are wants to have, that the what is the range of amplitude modulation? 0.8 to basically what is the amplitude modulation? Amplitude modulation, it is a ratio of to the reference amplitude. Yes, it is a ratio of means like you know fundamental to the reference amplitude, and the range of this one for the you have the 3 regions. I mean to say that over modulation, under modulation, okay, and then you have usually that you want to operate the modulation index between the 0 to 1, it will come under the linear range. Okay. If you go behind the modulation index greater than 1, it will become the what we can say that over modulation. Most of the cases they won't go for the over modulation case. In that case, that the output is going to be means like twisted, we will have the good control over the modulation index between the 0 to 1. That the amplitude that we will talk about this thing also modulation index part, but it is a one of the parameters to maintain that the linear region of your circuit. Okay. Then this is 7 level output that we are having, means like that the cascaded H bridge multi-level for the 7 level by increase one more DC source here. Okay. One more DC source, and then we will obtain the it is not this waveform is not this one. I will give then this the 7 level output that we are going to obtain by using cascaded H bridge multi-level. So, yeah, I can say that means like we have come across the basics of your multi-level inverter topology, flying capacitor, diode clamped multi-level inverter, and the cascaded H bridge multi-level. Any means like any basic questions regarding this part? Any questions on this concept? Then yes, the usage of the multi. Yes. 9 level with which this type of topology? Yeah. Yes. You yeah. Professor will give more insight on this thing.
Yeah, for high voltage application, you can go even more than 100, 200, something like this.
Any challenges?
What challenges the balancing of the system or controlling or this or that. It's depending on what you are expecting from the but if you are going to go very high, yeah, you need
Sir, for 100 or 200
Yeah.
level,
yeah,
the
yeah,
switching pattern will be very complex.
yeah.
Yeah.
Yeah, definitely. Yeah. But I'm saying that, for example, for HVDC system, if you are going to use. So what is the level? Maximum 12.
12 pulse.
I heard it can be also up to 400 level. Yeah. But probably you're right. But this is what I heard.
Yeah, added statement to this that in academic environment we will go for the number of levels, but when it comes to the industry point of view, means they won't increase, that the structure has to be standardized, then they will go for the multiple means like multiple units. They won't experiment with the higher number of level. If you come to our laboratory also, means like still they are in the means like 3 level, 4 level, 5 level experiments are more popular as compared with the higher number of level. If you go for the higher number of level, that the more means like the complexity is there, it is for the meant for the research purpose, not for the means like industry industry applications. That is one aspect that we can stress. Yes. Still some more.
Ask from Arya.
Yeah.
Could you repeat what was the question? Could you repeat what was the question?
Yeah. Question, can you, sir is saying. Okay, fine.
Okay.
Yeah. Yes. Anything means like this is the fundamentals. It is easy to go.
Multilevel units are most familiar in drives.
Drives application.
Multiple motor drives.
Yes, especially that the application part also, marine application, some kind of traction application, traction power supplies, and also then this kind of what we can say traction power supply, STATCOM application, HVDC transmission, means like some kind of steel manufacturing industry. These are of more popular. Yeah, more popular in traction applications and all these things. Yes. Yes. If the things are fine, means like what we are going to do, I have one more in that I am trying to cover the different modulation technique and the modulation technique that I am going to cover.
Okay, after lunch they should have
No,
the
no,
lab
no,
session.
not today. Means
Yeah.
like you are.
Yeah, tomorrow I start chapter 6 and
Okay.
then you have also time to,
Yeah.
because
Okay,
after
fine.
chapter 6
Hmm.
I mean everything is finished.
Yeah, okay, fine.
Yeah.
That this is the fundamentals only, not depth. Means like that the fundamentals to have glance on the to work with this kind of high power inverter that we are giving the some concept on it. Yes, fine. If you don't have, means like that here at least my simple question: what is inverter? What kind of conversion for the things? DC to AC conversion. Okay, at variable voltage, variable frequency. Okay, that is the conversion. You have the 4 types of, yes, AC to DC, DC to DC, DC to AC, and AC to AC. Okay, mostly that you want to see this kind of AC conversion, but you will have the DC AC conversion. Okay, with the variable voltage and the variable frequency. Yeah. Then fine, and you want to get control over your machine. What are the, how you are going to get control over your machine's part? Yes, DC machine is there. You have what type of machines are we are talking? Means like for the, no, machine's part, that the application. AC machine or DC machine? AC machine. Yeah, you are okay, but these people, AC machine. AC machine, and you have 2 types of machines. One is DC machine and the second one is of AC machine. Now the talk is on AC machine's part, sir is talking. If you want to have the control over the AC machine, what you require? How you are going to, DC machine and AC machines are there. 2 types of control. What control means? That is the speed control of your machine. Yeah. Don't go too much complication, just a simple thing that speed is there, your means like one motor is there, you want to get control over the motor part. Okay, speed I want to go at 0 kilometers per hour or 50 kilometers per hour. Okay, increase the rotations. How you can increase or decrease the rotation, rotor part? It is fundamental. Yeah, when it comes to the AC machine, that is the frequency and the voltage.
Yeah, we talk in previous session.
Yeah, and just that I am here to and the other thing, in DC case, just to increase the voltage, you can increase the speed. Okay, mostly that the in train application that you will see the DC series motors. Okay, and for power generation and some industrial application, that they will make use of the AC machines part. Okay, there you require the variable voltage and the variable frequency. Here only the DC voltage, that the things. Fine. Yeah, if the things are fine, we will close the session, or any means like that the queries, we can have some 1 or 2 questions from the participants. Yeah. 5
the control section,
uh,
from the controller we get the control action. Is it a 5-volt operated system or
yeah, yes, that is another thing, means like there will be like that the interfacing system is there. If the interfacing system is there, that what you can get, that it is a 5-volt system that you will programming with the computer part, and that is a 5 volt, and then for your system it requires the more voltage. Means like when it comes to this one, that the block diagram 5-volt system will work with the electronics, but when it comes to the power circuit, more voltage is required. In simple terminology, more voltage in the sense that you have the gate circuit, it requires the 15 volts. Your device, that will be of another, that is the power circuit. We will call it as three types of, one what we can say that power circuit, control circuit, and the interfacing circuit.
so we can use level shift as well.
Yes, level shifting operation that can be made you to increase from 5 volts to the 15 volts. That's the control aspect. Yes. So it is architecture. If you see that there are many components, that the PCBs will look very simple, but understanding it takes more, means like more complex. Any? Yes. Fine. Fine. Thank you for all, and we'll see you in the lab afternoon session. Okay. In smart electric grid laboratory in second floor of electrical engineering department. Yeah, fine. Thank you. You can add